So now let's move to numerical part. Okay. So yeah, there are almost 4 questions. So the 42nd question, as I said in my previous video, like mainly 42nd question is mainly from either electrostatics, any one of the chapters. Okay. So now yeah, it's basically a very simple question. So 4-point charges of 6 nanocoulomb, minus 3 nanocoulomb, plus 6 nanocoulomb, and plus 3 are placed at the corners of A, B, C, D of a square. So first, let us draw a square. Okay, and we'll just name the square as A, B, C, D. Okay, so along A, 6 nanocoulomb is placed, plus 6 nanocoulomb. On B, minus 3 nanocoulomb. And on C, again plus 6 nanocoulomb. And on D, plus 3 nanocoulomb are placed. Okay, and they are separated at a distance of side 0.2 meters. Okay, since it's a square, all the sides will be the same. 0.2 meters. Okay, now let us find the magnitude. They have asked us to find the magnitude and direction of the resultant electric field at the center of the square. So let me take the center of the square as O. Okay, fine. So now at the center of the square, what's the electric field to find out? So what we have to do is at the center, the total electric field is given by electric field due to A plus electric field due to B plus electric field due to C and electric field due to D. Okay, so yeah, so and we know the electric field formula, that's E equals 1 by 4 pi epsilon naught cube by r square. Okay, so this is the main formula of electric field. Now we know the sides of the square, so let us find out what is this distance from O to C, O to B, O to A and O to D. Since if this is 0.2 and this is 0.2, what's the value of AC? Using a Pythagoras theorem, AC will be equals to root of 2 of 0.2 the whole square. Okay, yeah. So basically, yeah, one second. So basically, yeah, it will be around AC. Yeah, so you will get something around root 2 times 0.2. Okay, so this is the value of AC, but we don't need AC, right? We need half of its distance because we are finding the electric field at the center. So half of its distance can be taken as OC can be taken as half of AC. Okay, so when you do half of it, you get 0.2 by root 2. Again, you rationalize and all, finally you'll get 0.2 by root 2. So the value of OA and the value of OB, value of OC, value of OD is equals to what? 0.2 by root 2. Okay, so now we have found its distance from the center we have found. Now let us quickly substitute over here. So before that, let us know that since you can see here 6 nanocoulomb and 6 nanocoulomb, they both are equal charges and they both are what? And they both are having a same polarity also, and they're in opposite direction. So we should be knowing that if an electric field here it is, electric field due to C will be outwards, again electric field due to will be outwards, therefore they both gets cancelled each other because they are having the same charges. So now electric field due to A will get cancelled and electric field due to C will also be get cancelled. So now let us find out what is electric field due to B and D, that is plus 3 nanocoulomb and minus 3 nanocoulomb. Okay, so first let us so let us find out E equals 1 by 4 pi epsilon naught cube by r square. Okay, so the value of 1 by 4 pi epsilon naught is 9 into 10 power 9, and the value of charge, what's the value of a charge there? 3 nanocoulomb. So 3 into 10 power minus 9, and the distance square. So the distance of OD is what? OA or OB, OC, OD is equals to 0.2 by root 2. So directly take 0.2 by root 2 the whole square. So what do you get here? 10 power 9, 10 power minus 9 gets cancelled. 9 into 3, 27. Root 2 square is 2. It gets multiplied there. And 0.2 square can be taken as 4 into 10 power minus 2. Because 0.2 square is 0.04, right? I am taking it as 4 into 10 power minus 2. I'll just take 2 1s 2, 2 2s are 4. And then 27 by 2 is how much? 2 1, 2, 2 3, 6. 13.5 into 10 power minus 2, if it goes up it is 10 power 2. Finally you will get 1350, and SI unit of electric field is Newton per coulomb. So this is electric field due to what? Electric field due to plus 3 nanocoulomb or minus 3 nanocoulomb, anything. I'll just take electric field at B. Okay. Similarly, you don't go with the plus or minus over here. Okay, so the electric field due to the minus 3 nanocoulomb is also the same. So what happens? The total electric field will be taken as 1350 plus 1350. So how much? 0, 3, 4, 5, 6, 7 and 2700 Newton per coulomb. That's it. So the total electric field is given by 2700 Newton per coulomb. Okay, so that's it. I think you can go it in a very simple way also, no problem. If not, if you want, because this is a 5-mark question, right? So you can solve what is the electric field due to 6 nanocoulomb. Okay, and then you can just tell that they both get cancelled with each other because they are having the same charges and they are in opposite in direction. That's the reason you can just tell that they both get cancelled each other. So the total electric field is due to what? Both plus 3 and minus 3 nanocoulomb. So this is the magnitude of electric field. Next they're asking, don't forget this, what is the direction of resultant electric field at the center of the square they have mentioned. So how to find the direction here? See now minus, okay, electric field due to minus, that is electric field due to B will be towards, right? So electric field due to B is towards, okay, because it's a negative charge. And electric field due to D is outwards, right? Because it's a positive charge. Again, it is over here. So finally, you can say that the electric field is towards the B of the square, point B of the square, because you can see here the net electric field is pointing towards B. Okay, so the direction you can mention like that. Okay, towards B of a square. Okay, so the net electric field direction is towards the B of the square. Okay, so that's it. This completes the first numerical of this paper. Now moving to the second numerical, that's yes, it's completely a Kirchhoff's voltage law. It's not quite tricky, it is, but if you apply the law and later it's just a simple mathematical technique. Okay, so now let me take this first loop. Okay, I'll take this as first loop and this as the second loop. Okay. Okay, so that's the first loop and this is the second loop. So first let me apply a Kirchhoff's law for loop 1. Okay, for loop 1, apply KVL law, Kirchhoff's voltage law. Okay, so let me apply Kirchhoff's voltage law. I'll go in this direction itself. Okay, I'm going in a anti-clockwise direction. You can go in any direction, no problem. Yes. So now I'll move from A, F, E, B, A. I'm going in this direction. So I'll start from here. I'm going in this direction. You can see here the current is over here and internal resistance is over here. So if I'm going in this direction, what happens? You will take plus of 2 times I1. Okay, and you are going from positive to negative. So you will take minus of 4 volt. Okay, minus 4 volt. Okay, minus 4 volt. And then you are going here and the current is in the opposite direction. Therefore, plus 4 times I1. Okay, I'm applying a Kirchhoff's voltage law. And then again, you will take plus 10 times I3. Okay, and then you are going in this way. Current is opposite to you. So plus 6, what is the current flowing through this? I1 equals 0. So now you can just take this as 2I1 plus 4I1 can be taken as 6I1 or plus 6I1 is there. So directly you can take it as 12I1 plus 10I3. Okay, minus 4 volt. If you move it in there, it becomes plus 4 volt. Okay, so now this can be reduced further as 6I1 plus 5I3 equals 2. Okay, so take this as equation 1. So this is applying the Kirchhoff's voltage law for loop 1. Okay, now let me apply the Kirchhoff's voltage law. Okay, apply KVL law for loop 2. For loop 2. Okay, I'll take this as a loop 2. I'll go from B, E, D, C, B. Okay, I'm going in this way. Okay, so now as I'm going from B to E, so current is in the direction minus of what's the resistance here? Minus 10 I3. Okay, and I'm going in this way. Yeah, current is along with, so I'll take -4, and the current flowing through this is I2. Okay, look at the current there, -4 I2. Okay, and negative to positive, so plus 2 volt, and in the direction again minus 1 I2, directly I'll write as I2, and then in the direction, so minus 6 times I2 equals 0. Okay, so now minus 10 I3, okay, plus 4 I2 minus I2 minus 6 I2. So how much will you get? 4, 5, and then minus 11 I2, okay, plus 2 equals 0. Again, I'll take this as 10 I3, okay, plus 11 I2 minus 2, I'll write it as equals 2. So this is equation 2. Okay, so now just like this, you apply the Kirchhoff's voltage law for both the loop 1 as well as loop 2. And now let me apply a Kirchhoff's law at this junction B, guys. Okay, so at the junction B, you can see here I1 is entering the junction, I2 is entering the junction, whereas I3 is leaving the junction, right? So let me take this as I1 plus I2 as I3. Okay, so take this as equation number 3. Okay, so now what you can do here is, let me substitute this. Okay, here I3 plus I2 is there. Okay, let me substitute equation 3 in equation 1. Okay, so 6 of I1 can be written as I3 minus I2, right? So I'll directly take this as I1 as, from this equation 3, I'll take I1 as I3 minus I2, okay, plus 5 I3 equals 2. Okay, further if you reduce, you get 6 I3 minus 6 I2 plus 5 I3 equals 2. So finally what do you get? 6 plus 5 is 11 I3. Okay, 11 I3 minus 6 I2 equals 2. I'll get my fourth equation. Okay, I'll take this equation as equation number 4. Okay, I hope it's correct. 6 I3 minus 6 I2 plus 5 I3, whereas 6 I3 plus 5 is 11 I3 minus 6 I2 equals 2. Now you can equate this equation 4 and equation 2. Okay, so let me, I'll just take it over there instead of moving to the next slide. Okay, 1 minute. So I'll just take equation number 2, 10 I3. Okay, so 10 I3 plus 11 I2 equals 2. Okay, 10 I3 plus 11 I2 equals 2. 11 I3 minus 6 I2 minus 6 I2 equals 2. Okay, so now to equate this, what we have to do here is, let us multiply, I'll multiply this by 6 and I'll multiply this by 11. So what you get? 10 into 6 is 60 I3 plus 66 I2 equals 6 into 2 is 12. 11, 121 I3 minus 66 I2 equals 22. So now you can see here 66 plus 66 I2 minus 66 I2 gets cancelled. Okay, so just add this, you will get 1 I3 equals 34, whereas I3 will be equal to 34 by 181. Okay, so from this loop rule, what we found what is the value of I3, because I3 is flowing across 10 ohm, right? Now our main question is, find the potential difference across 10 ohm resistor. Okay, so the resistance is 10 ohm. For current you found out, I3 I found out to be 34 by 181 ampere. Now directly you can substitute in an equation V equals Ri, where the resistance value is how much? 10 ohm, and the current value is 34 by 181. So how much will you get? You will get something around, so the voltage across 10 ohm will be 1.878 volt. That's it. You should be getting 1.87 volt. That's it. So this completes the answer. Just apply the loop rule over here. Okay, once you apply the loop rule, that's a voltage rule, you will get finally the value of the current, and the same current value you can use it in the voltage formula. That's Ohm's law formula. Okay, so that's it. Now moving to the next question. Yeah, this is a most simple question. So write what is given. Inductor is 0.194 Henry. Capacitance is 35 microfarad. Micro is 10 power minus 6 farad. And then a resistor of 40 ohm. R is given as 40 ohm. Okay, and connected to a source is how much? 200 volt, and frequency is 50 hertz. Okay, so the first they're asking us to calculate what is the value of impedance. Take Z equals root of R square plus XL minus XC the whole square. So we know this formula. You should be knowing this formula. So Z equals root of R square plus XL minus XC the whole square. So first find out what is the value of XL. XL is given by L omega. Okay, so the value of L is 0.194. Omega is 2 into 3.14 into F is how much? 50. So you will get 314. So the value of XL is yeah, 1 second. Okay, so the value of XL will be 60.95 ohm. Please solve this. Okay, you will get around 60.95 ohm. Okay, next to the value of XC. XC is given by 1 by C omega. Substitute what is the value of XC? You will get something around 90.93 ohm. Now substitute this in this equation. Z equals root of R is given as 40 square. Okay, so XL is 60.95 minus 90.93. Okay, so you can take this as XL minus XC the whole square. Yes. Okay, so you will get root of 40 square is 1600 plus you'll get something around 30 square is 900. So you will get 1600 plus 900 is 2500. Okay, so the root of 2500 is 50. Okay, and SI unit of Z is ohm. That's it. Okay, so you will get the value of Z as 50 ohm. Okay, very simple. Next, power factor. Second sub question, power factor. So power factor is given by what formula? It is cos 5, right? So cos 5 equals R by Z. So the value of R is how much? 40. The value of Z is 50. So how much will you get? 40 by 50 to be 0.8. That's it. So the value of cos 5 is 0.8. Don't take 5 equals cos inverse of, because they're not asking you phase angle here. They're asking you what's the cos 5 value. That's it. I mean the power factor value. Okay, fine. So yeah, this is a 5 mark question. Okay, now moving to the next question, the last question. Okay, this is a most simple question because it's a great in syllabus as well. Yeah, from ray optics. So first write what is given. So height of object, right? Height of object, directly take it as h. 3 millimeter. Okay, if you want you can convert it to centimeter also, or keep it in millimeter. Fine. Okay, next it is placed at a distance of, so u equals 14 centimeter and concave lens of focal length. Focal length is how much? 21 centimeter. Now they're asking you to find out what is the position of the image, nature of the image, and size of the image. Okay, so these are the 3 things what they're asking you to find. So before that, let us put the sign convention. Okay, so as we know, u is always negative, and since this is what lens? This is concave lens. So focal length for concave lens is always negative. For both mirror as well as lens, focal length is negative. Okay, so now let us use the lens formula over here. Okay, so lens formula is given by 1 by f equals 1 by v minus 1 by u. So we are finding position, right? That's v. So 1 by v equals what? 1 by f plus 1 by u. Okay, so the value of f is minus 21, u is minus 14. So directly you take 21 into 14 as, okay. Okay, so how much will you get? 294. So 294. So minus 21, how much times 294? 14 minus 21. So you get 35 by 294. So you will get minus 35 by 294. Okay, so 1 by v is minus 35 by 294, whereas v is given by minus 294 by 35. So you will get v value as how much? Minus 8.4 centimeter. Just calculate once. 294 divided by 35, yeah, minus 88.4 centimeter. So this is the position of the image formed to be how much? Minus 8.4 centimeter. So we found here minus 8.4 centimeter. Since here V is also negative, so what type of image is formed over here? Okay, it's a lens. Okay, so image is formed in front of the lens, right? So that's the reason the nature of the image formed is what? Virtual and erect. Okay, this you should be knowing. Based on the sign convention, you can easily say that it is the image formed as virtual and erect. Okay, now to find the size of the image, that is h dash, okay, height of the image, we have a magnification formula, right? H dash by h equals what? V by u. So h dash will be equal to V into h by u. Okay, so the value of V is minus 8.4. Okay, the value of h dash is how much? 3 millimeter is 30 centimeter. Sorry, 0.3 millimeter. Okay, I mean 0.3 centimeter. Okay, and the value of u is minus 14. Minus minus cancels. How much will you get? Just calculate this. So you will get 0.4. Okay, so 0.18. I've converted this in centimeter, guys. So the value of h dash, I'm taking it in centimeter. Okay, you can take it in meters also or millimeters, whatever you wish to do, you can do it. Okay, so the final answer is 0.18 centimeter. Okay, fine. So this completes the numerical part. Okay, so if you have any doubts, you can drop the comments in the comment section. Okay, and don't lose hopes if you have not done well, because this is not your final exam. Okay, this is something where you guys have to learn from the mistakes what you have learned from before. Okay, so I think this is something a learning stage now, and don't compare your marks with others. You just compare with yourself. Okay, like yourself with what you were previously. Okay, so that's it. Thank you all. Bye.